welcome back. Our first talk this afternoon is going to be by Sakib Khan Inan and Rubaiath E Ulfath, and they're going to be talking about time series forecasting. So take it away, guys.
Yeah.
Hi everyone. So I'm Sakib. I'm a PhD candidate at Deakin University, and this is.
My name is Rubaiath, and I'm a PhD student from RMIT University.
So we both work on time series data for our PhD projects, and the talk we are giving today is time series analysis in Python, easy tools for scientific insights. So it's a pretty basic talk, but what we want to get from this talk is basically some introduction to time series and what are the tools that are available in Python and how can you get started with those tools when you're working with time series, and maybe how easy it is to work with time series. So if you want to start, we want to talk about what is actually time series, right? So when we talk about computer vision, images, text, I think we all know about what the images look like, what the text look like. Normally, time series data, what's special in it is when you have features, when you have numbers in other AI or machine learning related problems, they are not ordered over a time period. So the features you have, they don't have time-related relationship across them. But when you have some kind of data, when you have some numbers, let's say sequence of numbers, and those sequence of numbers are connected to each other based on time, so they have time dependency, they have some order that you need to maintain, like who come after who is a big fact, then we call it time series data. And normally, how the time series data look like is something like this. So I think you have maybe seen different kind of time series data. They more look like a signal. Here, there are some different signals. All of the different signals can be considered different kind of time series sequence. And all of them are kind of dependent across the, let's say, x-axis based on time. So the x-axis you can think of, it's a time, and for the y-axis you can think of there's different values. And this could mean different things, like for example, it could mean temperature data, it could mean ECG data, it could mean electricity demand, it could mean stock market data. So time series is kind of everywhere, and those time series come from different kind of domains, different kind of applications. So yeah, so if we want to talk where we can find series, where we can find time series, it's pretty much everywhere. So it starts from environmental monitoring or medical or health science, energy, astronomy or space science, finance, everywhere. So the application of time series is kind of everywhere. So it starts with even smart watches. Like whenever we actually wear smartwatch, we measure our walking data, we measure our heartbeat, a lot of different things. Those data, all of them are actually time series data, and we are dealing with time series data across different applications everywhere. So it is very much important to understand how we can work with time series, how we can make the best use of this time series data, how we can gain practical insights from time series data. And when it is basically age of AI and machine learning, we all maybe want to know what are the methods that are available with time series data for time series analysis. And what are the tasks that we can do with time series analysis or time series data? And why this talk is important and why we need to know about, let's say, some Python libraries that are available on time series. I think it's because when we talk about other type of data formats or data type, when it comes to, let's say, images or text, and when it comes to AI using images and text, there's a lot of resources, and all the big libraries like TensorFlow, PyTorch, by default, they support working with image data or text data. But even though time series data is almost everywhere in many different applications, it is used and it is regularly, it's a pretty much area where a lot of researchers are working for developing novel methods in the machine learning or deep learning space. But I don't think there is a lot of discussion around the time series kind of libraries. Even the TensorFlow and PyTorch, those type of libraries, does not natively support the use of time series. So basically, you maybe need to do a lot of wrapping around. You maybe need to write a lot of custom functions to handle time series. So that's why I think this talk is important to get to know what are the available libraries and how can you start working with time series pretty much easily. So for this talk, there will be so there are a lot of time series tasks, but majorly we are going to focus on two major time series tasks throughout the talk. One is time series forecasting, another is time series classification. We'll come to that later, but we will also have some bonus discussion on time series anomaly detection. But let's see how those tasks actually look like for the beginning. So time series forecasting is all about, let's say, you have some data, which we call historical data. That will be a time series data. And based on that historical data, you want to predict future instances that is dependent on time of that particular data. That is what we call time series forecasting. For example, in this graph, you can see the blue line is a historical data, and maybe the orange dashed line is a future data. So when we do time series forecasting, what we want to do is we want to use the historical data, the blue line. We want to learn some patterns from that blue line, and we want to predict how the blue line is going to be extended in the future time step for a particular period of time. That is what we call normally time series forecasting. And time series forecasting is used in so many different places. One of the most common places may be energy demand forecasting or weather forecasting, like the forecasting of temperature, forecasting of humidity that we maybe use in our everyday regular life. And stock market forecasting, maybe we are also a lot of interested about how the finances are going on, how the stock is going on. So a lot of different domains actually depend on time series forecasting. They want to see the historical data, and based on the historical data, they want to predict how that data, how that time series pattern is going to be extended for future time step. So that's pretty much all about time series forecasting. Next part is time series classification. In the previous slide, we saw time series forecasting, but the time series classification is similar, but it's a little bit different in some cases. For example, in this case, we don't want to predict the future instances of an historical data, but we want to group historical time series data into, let's say, different clusters or different groups. So let's say we have different kind of time series signals or sequences here. Based on their pattern or based on their different features, we want to group them in certain classes or certain labels. We might want to annotate the data. That is what we call time series classification. You just look at the time series data, you just identify some unique patterns from the data, then you divide it into classes. It is mostly used in different kind of application. Some of the examples are heart disease detection, human activity recognition, or fault diagnosis in industrial use cases or different kind of applications. So yeah, it's pretty much important in all of the different applications that deal with time series. For example, if someone is having a heart attack or someone having an abnormal heart rate, that could be easily classified when you have a time series data of heart rates or ECG type of things. And that's pretty much falls into the category of time series classification. And for the rest of our talk, we will be discussing some libraries, Python tools basically, that can help us to explore this type of problems, basically work with this type of problems and solve this type of problems in different domains. But there's a bonus, as I say, there's another kind of task which is also popular, which is called time series anomaly detection. So there are also very other time series tasks like time series clustering, time series annotation, but we are not going to extend to those things. But what is time series anomaly detection? Anomaly detection is quite simple. You have a time series. That time series might have some, let's say, irregular peaks or some noise in the data, which you want to identify, which you want to figure out. So that's anomaly detection. So you have a series of data, you have a sequence of values dependent over time, then you want to identify from which time step to which time step there has been some anomalies, there has been some peaks, there has been some maybe irregular noise, those type of things. Why it is important? Because it can solve us different other problems, like it can give us early health warnings, it can help us to monitor product quality, or even it can help us to actually monitor or, let's say, solve network security related problems. So even anomaly detection in time series is also a really popular area. And the libraries we are going to discuss today, they also have support from time series anomaly detection. One of the libraries basically have support from time series anomaly detection. But most of the things, when you work with time series, there's some pretty much commonality, and there's some really overlapping things which can help us to work. If you're working with any one problem of time series, then it might be easier for you to get into other kind of tasks later on, because there are similarities when you work with those time series data, but also there are a lot of differences. So when we say time series analysis, right, what we actually mean is we want to learn some kind of patterns from the time series data. For example, if you are doing a forecasting problem in time series, some of the most common patterns that you might want to learn from the time series data is basically these things. For example, it could be trend, it could be seasonality, it could be a cyclic pattern, it could be irregularity or noise. So after you have learned, let's say, this type of pattern, or you have extracted this kind of pattern from a time series data, what we basically call time series data analysis, you can use that pattern or knowledge to really forecast values in the future, or group the time series together into a particular group, which we call classification, or detect if there is any abnormality or anomaly in the sequence data of time series. For the next part, we are going to start discussing some popular libraries for time series tasks. There are a lot of different libraries. We picked just a few libraries here, maybe the most popular one or the ones we most love, but there are also other libraries too. So if I quickly started, one of the libraries is Sktime or Sktime. Other library is Nixtla. Nixtla is not only a library, but it's a kind of an ecosystem. And there's a very new one, which is called Aeon. So Sktime and Aeon, they have a lot of similarities. Later on, I will have a slide where I will basically show you what are the similarities and differences of across this ecosystem, or some libraries from the ecosystem or from the fleet of those libraries. So in all of these libraries, or all of this Python ecosystem and time series, one thing which is common is they have the API interface designed in a way that is similar to scikit-learn. I think if you have worked with machine learning or deep learning type of problem, mainly machine learning, let's say machine learning, and if you work with tabular data in machine learning, I think a lot of people start their machine learning journey working with tabular data in machine learning. Then maybe you have more familiar with this scikit-learn library. You may have used the scikit-learn library to develop machine learning models on tabular data sets. So Sktime and Aeon and even Nixtla's libraries, what they do is their API interface is highly similar with the common API interfaces of scikit-learn. So you have the same fit method, or you have the same predict method. Let's say the fit method is used for training models, and the predict method is used for predicting the future data after you have trained models, right? Predicting even forecasting, classification, whatever it is. So scikit-learn has that API structure or interfacing that is exactly similar when you're working, at least in the front end, for all of these libraries. So if you're coming from a scikit-learn background, I think you won't be feeling, let's say, an alienated situation, but you will find a lot of similarities. And whenever you go through the, let's say, examples, you will find, okay, this particular method I have seen in scikit-learn, maybe some of the methods you have seen in TensorFlow too, like TensorFlow also uses fit and predict, and that will be maybe easier for you to grab the concept and get started with time series and working with all of these libraries pretty quickly compared to maybe some other libraries which may not follow the scikit-learn-like interface. So we will go one by one of this from these libraries to discuss what's there. The next part will be discussed from our next speaker. Yeah.
Thank you, Sakib, for your nice explanation. So I'm going to talk about the Nixtla. Nixtla is basically a time series forecasting ecosystem written in Python. Basically, it contains all type of open source libraries. So it has 3 different libraries: NeuralForecast for deep learning models, MLForecast for machine learning models, and StatForecast for statistical models. And the NeuralForecast is written on PyTorch, and for the efficiency purpose, it is supported by Numba. And on the other hand, the MLForecast and StatForecast are basically work as a wrapper. And here are some examples of the algorithms. In NeuralForecast, it's amazing that they have more than 30 deep learning model classes. And like a lot of them are very recent state-of-the-art deep learning algorithms. So if anyone want to start time series forecasting with deep learning models, they can get everything in their website. So, and also, beside the algorithms, they have their auto model as well. So auto models are written using the Optuna and other hyperparameter tuning optimizers, so that we can easily optimize the algorithm by tuning the hyperparameters. And before training our model, we need to prepare the data. So here I have put an example from the Nixtla website. So this example is preparing the data to predict the air passenger. And here you can see in the table we have 3 columns. So these are the minimum criteria when we want to build a time series forecasting model. So it basically takes the pandas data frame, and the 3 columns are the unique ID. The unique ID is important when we want to do the multivariate forecasting, because in multivariate forecasting, we want to predict multiple time series. So that unique ID helps us to distinguish between the time series data. And of course, there would be a DS column, which is the timestamp, and we have our target variable Y, which is the number of air passengers, and this is a monthly data. And after we have our pandas data frame, we now can start building our model. So another interesting thing about the NeuralForecast library is that we can write multiple algorithms in a list. For instance, here we can see that LSTM and NHITS, 2 of the popular time series forecasting algorithms, mainly deep learning algorithms, are written in one list to build our model. So we don't have to write separate separate codes for each algorithms. And of course, each of the algorithm will have their own parameters, but 2 of the parameters would be same. One is the input size, and another is the forecast horizon, or we can say horizon. Because in time series forecasting, we train our model with the sliding window approach. So the sliding window has 2 parts. One, the input length, like the his past data point, the model will learn, and then it will predict the horizon, like the future data points. And when we build our model, we give it to the NeuralForecast class, and we call the .fit function to train our data frame with the data. And after training our algorithm, we need to have the .predict method, which returns the data frame with a forecast for each unique ID, DS, and models. Then we will have our prediction results. As you can see in the table, that LSTM and NHITS prediction side by side, so we can compare which model is doing like well or not. So these are my things. Yeah.
So we have already seen about the Nixtla, basically NeuralForecast, how the NeuralForecast actually works. We're going to quickly see another library, which is Sktime. So Sktime is one of the biggest library for time series classification, forecasting, and normal detection or clustering or more. So the best thing about Sktime is it's purely written on top of scikit-learn. So it has all the different models that you can find, like ARIMA, Prophet, AutoTS, NeuralForecast. Even it has some libraries which can support the models from NeuralForecast natively. So let's maybe just have a quick example, like how you do forecasting with ARIMA in Sktime. It's pretty simple. It's just like scikit-learn. You have this forecaster. You just call the ARIMA model. Then you build the model. You call the fit function over the data that just fits the ARIMA model on the data you have. And then you just predict the values using forecaster to predict. So it's quite similar how Nixtla does and how scikit-learn does. And if you look at the time series classification, that is also pretty simple. Let's say you have a time series algorithm that you want to apply. This is one kind of machine learning algorithm for time series data. You can just load the time series data here exactly as you do in scikit-learn, very simple. You just call the fit function again. You pass your data x and y, as is a time series classification problem. You have labels. Then you just predict the things, and you calculate the accuracy. So quite simple, quite straightforward, I would say. And in time series domain, there is a lot of transformation method. Just sometimes you don't want to do classification, forecasting, or other tasks, but you want to extract some features, like statistical features, or you want to do data augmentation on time series. And that is also pretty simple. There is a lot of time series transformation method, like catch-22, mini-rocket, rocket, those type of algorithms that helps us to, let's say, transform the data or extract features are very easily available, and you can access it with this fit transform method, just like scikit-learn again. And if you're working in the time series research domain, you want to try out different algorithms on your data, and you want to build a benchmarking. Good thing about Sktime is they have some frameworks for benchmarking for both forecasting and classification. They have all the benchmark data set and the benchmark experimental setting. For example, they have the UCR and UEA benchmark data set, which are used in time series classification. You can just fetch those data sets, just fetch the experimental design pretty quickly by using this kind of framework. And that is pretty much straightforward when you're working with time series type of problem. And this is a quick example of Aeon. You will see the Aeon is built on top of Sktime. So whatever you get in Sktime, you will also get it Aeon too. So that is pretty much similar to Aeon. There's a final summary. This final summary actually gives us a comparison how the libraries, the major libraries, look like side by side. You can see the NeuralForecast is a new library, but it's still a mature one. Sktime is the oldest, and it's pretty much established library. Aeon is quite young. It is built on top of Sktime, but it's rapidly developing. NeuralForecast is built on top of PyTorch. Sktime is built on top of basically scikit-learn. And Aeon is basically forked from Sktime recently, and they're working to develop it. There is some MLOps support. For example, NeuralForecast natively supports PyTorch Lightning as it is developed on PyTorch. Sktime supports MLflow by natively. And Aeon also supports MLflow in a native manner. So it is pretty much very easy to work with this library. And these are the quite few similarities and some differences. All of them also support NumBuff, not even for all the algorithms, but at least for most of the algorithms, I think you will find number support. So the efficiency is also covered. But NeuralForecast only support forecasting. That is morely focused toward forecasting type of problem. But Sktime and Aeon are morely generalized type of library. They have all the different supports. But yeah, I also like NeuralForecast a lot because it has the PyTorch implementation, and the custom model building part is also very easy. But you can work on that too in Sktime and Aeon. End notes. So this picture is from the Aeon paper. Recently, it's published on the Journal of Machine Learning Research. This is a tool, but then again publish it as a paper. It's just a quick view, like, do you really want to work with time series data, or do you need to really work with time series? For example, this is a graph where you can see where if you want to start time series, you might need to look at this workflow to decide whether or not you need to start with time series, or if you have already started with time series but you are not sure what type of time series task do you need to work on to solve your problem. This flow chart also gives you an idea whether you should go for classification, whether you should go for forecasting, or any other problem like clustering, segmentation. This is a pretty good flow chart, a pretty comprehensive flow chart. You can have a look and analyze, decide whether or not you should start with time series and what type of time series analysis task might be the best fit for your problem or your research that you're working with. Thank you for the, thank you so much.
Thanks, guys, for that great talk. So we have to say thank you, a stylish and practical Python mug.
Thank you.
Unfortunately, we don't have any time for questions. We're a little behind schedule. But if you guys want to catch them in the lobby or whatever and ask them, I'm sure they'd be happy to answer anything. So,
Thank you so much.
cheers.
Thank you.
Thanks again.
Thank you, everyone.